Okay, side-by-side box plots and back-to-back stem plots. I've got an example here where we've got two brands of nails. We've got some data on them which concerns their strength. I've already got the jump on you here because I've already started mine, and I've started to put the data from SteelFix here, and I'm telling it on my stem plot on this side. The Holdwell data I'm putting on the other side of the stem plot with the same stems. So this number here is this stem, and the leaf here, put these together, this 17.5 means 175. Put that in the key. 17/5 equals 175, and these are measured in newtons. Okay, now I've just done this in pencil because once you've done your raw data, you need to rub this out and present it in order of size. Now the important thing here, in particular, we're familiar with doing these for single plots. That shouldn't be too hard to organise in order of size, but over here we need to make sure that when you do it, the smallest number is closest to the margin. So 5.5 is correct, so 0.4 is correct, with the smallest closest to the margin. This line here I'm going to rearrange in order of size, starting with the smallest leaf closest to the margin, and work back in this direction. So that'll be 2 first, then 3, 3, 6, 7, 9, going in that direction. Okay, I'll just do that one so we can see. Have to remember them. What did I say? 2 first, then 3, 3, 6, 7, 9. Okay, I'm going to rub the rest out, rearrange it in order of size. Would you like to catch up and see then if you can have a go at working out the quartiles and medians? Okay, now we've got the data here, organised in order of size. Stem plots, they're complete. We've got to work out the medians and quartiles. You could do this on your calculator if you wished, but it's not too hard. 24 pieces of data, so the median is the 24 plus 1 over 2. That's the 12.5th score between the 12th and 13th. 1, 2, 3, 4. The median's going to fit in there somewhere on this side. So that'll be 195.5 for SteelFix. And same on this side, 12.5th score. So it'll be, a median will fit in here. I'll just put it in there. So that would be between 204 and 206. That will be 205 for the Holdwell brand. Okay, now those numbers divide each group into half, and in the lower half of each data there will be 12 pieces. In the upper half of each there will also be 12 pieces, and so with 12 pieces of data, the median or middle number is 12 plus 1 over 2. It'll be the 6.5th score. 4, 5, 6. So for SteelFix, between 188 and 189, the lower quartile. SteelFix's lower quartile is 188.5. The upper quartile, count through 6, between 6 and 7 scores. 1, 2, 3, 4, 5. The 6th score is 199. The 7th score is 201. Between 199 and 201 is 200 is the upper quartile. Okay, let's just pop him in there. Okay, let's do the same thing for the whole world data. Between the 6th and 7th scores, 1, 2, 3, 4, 5, 6. They're both 193. So the lower quartile is 193. Upper quartile between the 6th and 7th score in the upper half, 1, 2, 3, 4, 5, 6, between 209 and 210. That makes it 209.5. So let's just put the upper quartile there. Well, we've got most of the data there. We've just got minimum scores to go. 175 for Holdwell, 183 for Steel Fix. Maximum scores 235 for Holdwell and 211 for Steel Fix. Okay, I'm just going to pause and put my paper up, and then we're going to have a go at doing those box plots. Okay, so to do the box plots, we draw a scale on here. Now we've got to have a smallest number of 175 and a biggest number of 235. I think we're going to have to probably go up here in 5 squares equals 10, so I'll start from 170. That'll be 180. 190. 200, 210, 220, 230, and that'll fit okay. 240. Okay. Now, while the tape was paused, I just did a quick check here, and I think you'll find that that maximum value, this 235 for the whole world data, actually makes it an extreme value. It's an outlier. This number here is more than 1.5 times the interquartile range above the upper quartile. The interquartile range, take away quartile 1 from quartile 3, worked out to be 16.5. And if you add 1.5 times 16.5 onto this number here, it's just a bit less than the maximum. So the maximum is in fact an outlier. So we're going to include that on our diagram, but just as a little x for 235 for the whole world data. 235, it'll be here. I'm going to indicate that as an x. And then I'm going to put the rest of the whole world data on here as I'm going to start by drawing a line between 175 and the next highest piece of data here was 220. Then a box, and the box has to go between the upper and lower quartiles, so from 193 up to 209.5. There. I'll draw a box. And and marking the median. The median is at 205. And there's our box plot for the hold well data. Now let's do it for steel fix. So a line from 183 to 211. And a box from 188.5 to 200. With a median value of 195.5. Just rub out that little middle bit. That was steel fixes data. Okay, what I'd like you to do is, can you pause the video now and see if you can work out some of the answers to this last two questions, and I'll be just back in just a second and having thought about my answers too. Okay, we're back and I've written a bit of an answer here. What I like to do with these things is I like to compare them based upon their best nail, in this case, their upper quartile, their median, their lower quartile, and their weakest nail. Now, the Holdwell brand, you can see here, compares best on maximum, upper quartile, median, lower quartile, but the steel fixed, it was actually strongest when you were to compare their weakest nail. When you're doing this, there's an outlier in the group. Now, it's difficult to say whether or not you should include that in your comparison. You see, that result might have been there, and it might have been a typographical error from the person who's taking the data, or for some other reason it may have been recorded wrongly. So it may be unwise to include that when you're talking about it. Then again, it could have been real data, and so it's best probably not to ignore it altogether, but just to take that into consideration when making your comments. Now, in this particular example, it didn't really matter whether or not we included it. Holdwell still had the strongest nail, even if you take that one out of consideration. Now, another thing I usually like to do, I take the medians into account. That makes a very good comparison, comparing the middle nail with each. And in an answer like this, I like to put some quantitative measure. So I was able to say that Holdwell's median nail was more than 10 newtons stronger than steel fix's median nail. Now, the things against Holdwell is it did have the weakest nail, and it showed variability in its results. With steel fixes, they're quite consistent, and at least you, with a steel fix nail, you know what you're buying. Whereas with a hold fix nail, it may be strong or it may be weak, which is the better brand. Now, with this sort of thing here, you could write an answer either way. I actually decided to go for a hold fix because, generally speaking, they're a whole lot better. They seem to be better on most of those indicators than steel fix. If you go back to the original data where we did those box plots too, you can have a look and you'll see that in fact there were only 3 out of the 24 hold wheel nails that were actually weaker than steel fix. So to me that seemed to indicate that hold wheels were the superior nail for strength. You may write a good answer though and say that steel fixes a better nail. You could say for consistency, at least you know what you're getting. Then again, if it's consistently worse than the hold wheel, consistency isn't always necessarily a good thing. But probably the reason I would probably tend to, if you did go for steel fix, you could, and you knew something about the nails, if they were nail gun nails, you can't really afford to have a weak nail in a nail gun. If the nail breaks in the gun, it can do a lot of damage to the nail gun, and that could cause a lot of delay in your building work and bits and pieces. You really couldn't afford to have a weak nail. If that was the case, then these weakest nails here are going to be really important, and perhaps those, you don't want to have those 3 weak hold wheel nails if they're going to cause problems, and you could then say steel fix was the best.